Bismillahirrahmanirrahim. In this video, we will discuss the basic operation of a converter circuit, which consists of a simple switch. So, the constant DC voltage is applied, and you have a semiconductor switch that is either a BJT, IGBT, or the MOSFET, and you control it by applying the gate signal or the base signal. And here you are going to connect the load. And for the time being, we are going to assume the resistive load. So, let's suppose that the resistance is R. In the last video, we have seen that this switch is basically going to amplify that one. Whatever is the input voltage, when you are going to turn on that switch, that will appear across the output that you can see over here. However, your control signal over here will be of the small voltage level, that may be of 3 volt, maybe of 5 volt, maybe of 12 volt or 15 volt. Usually this is the voltage range for the control signal. But your output voltage level will be equal to your supply voltage if there is no voltage drop over here, right? But in the practical case, there will be a small voltage drop. So, how you calculate the average DC output? So, we are going to represent it with this VAV, or we sometime will also represent this average voltage with this signal, with this symbol, right? Two brackets. So, the average voltage over here now will be equal to 1 by time period integration from 0 to T on, because up to this interval from here you can see you have the output voltage and then you have the 0, right? The total time period is T. So, if I mark the total time period, that is this one, T, from this point till this point, but out of that we have two parts, T on and the T off. On time is equal to dt and the off time is equal to d prime into T, as we discussed in the last video. So, how to find out the output voltage? Output voltage is equal to Vs when your switch is in the on state. So, we are going to integrate it with respect to the time. So, we are going to get it like that, T on by T into Vs. So, we can say this is equal to duty cycle times Vs, because Tn over T is the duty cycle. So, output voltage is calculated with the help of this one. Now, if I want to calculate the average current at the output, so that now we can simply calculate by taking the average value of the voltage divided by the resistance. So, that is can also be written like this. So, this is equal to D into Vs, where Vs is your supply voltage divided by R. So, you will get the average current through your load resistance R. Okay, now what will be the RMS value at the output that you can calculate now? So, Vrms will be equal to 1 by time period from 0 to T on, conduction time at your output, and you will be taking the square of the output voltage. So, Vs square into dt and then taking the under root. So, you will get the RMS value. So, if you simplify this one, that will be equal to T on by T into Vs square, and then the under root of this part. So, this will be equal to under root duty cycle times Vs. So, output RMS voltage will be obtained by multiplying the duty cycle with the input voltage Vs. And how to get the RMS current at the output? So, RMS current will be equal to Vrms divided by R. So, that can be now written as under root D into Vs by R, right? Okay, now what will be the power at the output, power delivered to the load? So, over here we want to find out the power. So, that can be calculated with the help of this expression, that is integrating your product of the voltage and current over the time period from 0 to T on, because for this interval of time your switch is in the on state that you can see and the power is delivered to the load. But we are taking area under this curve, the product of the voltage and the current, and then we are going to take its average value over this cycle. So, this is the average output voltage that is delivered to the load that we are going to calculate. So, we are going to find out the area under the product of the Vs and the current at the load, and the load current is Vs by R, right. So, when the switch is in the on state, when the switch is in the on state, so this voltage Vs is over here and the load resistance is R. So, what will be the load current? I will be equal to simply Vs by R. So, that you can see over here, this is the load current into the load voltage. When your switch is in the on state, output voltage is Vs. So, taking the product of this one, you will get the power, and now you are going to take its integration with respect to the time, and the time limits are from 0 to T on, and for average power we will divide it by 1 by T. So, if you simplify this one, so your output power will be equal to duty cycle times Vs square by R. So, this is the power that is delivered to your load, average power in one cycle. And similarly, you can look at the input power of this converter, so that will be equal to, let's suppose that is equal to Pi. So how you can find out that one? That will be equal to 1 by T integration from 0 to T on, right, Vs into the input current, that is the supply current, over this interval of time, the product of these two. And now if you simplify this one, so input power again will be equal to duty cycle times Vs square by R. Your input and the output power will be equal to each other, because we are neglecting the losses. We are considering that there is no power loss, right? Okay, now when your switch is in the turn on in the on state, then the power is delivered to your load, and when it is turned off, no power is delivered to the load, but the average power that is delivered, that can be calculated by this one. So now this resistance appears on average different at the supply terminals, because if you consider a cycle, in one cycle, for this time you are delivering the power, and over here you are not delivering the power. But now if I say what is the average resistance that will be appearing across the supply terminals in a cycle, what that will be equal to, because the resistance is turned on and then it is turned off. So how you define the average resistance? Average resistance is, you can say, is calculated by looking at the supply voltage and the current that is delivered by your supply on average, right, in a one complete cycle. So I can write it like that, Vs by I average, so that will be equal to Vs divided by, what is I average? I average is D into Vs by R, that we have just calculated over here, that is the average current, right? So taking the ratio of these two, you will get the average resistance. So this, if you simplify, will be equal to R over D. So the resistance that will appear at the source terminals over here, at the input over here, so this source will see that the resistance is R by D over one cycle, and the power will be delivered according to that one, and that you can see over here, Vs squared divided by R by D, and D has gone over here, that is representing the output power. So output power is basically according to the average resistance connected at the converter circuit, right? So the input power, the input resistance R in will be equal to R divided by D, right? So the effective resistance at the source terminals changes as you are going to change the duty cycle. Now let us consider the losses in the switch, specifically the voltage drop. So when your switch is turned on by applying the gate voltage, there is the voltage drop across that switch. So let's suppose that your output voltage is now the equal to V naught minus the Vs minus the voltage drop across the switch. So what will be the DC output voltage, average DC output voltage? That will be changed now. So now let's calculate that one. So V average will be equal to 1 by time period integration from 0 to T on, but now the load voltage is Vs minus the voltage drop across your switch. So integrating this voltage with respect to the time. So if you simplify it, so that will be equal to D into Vs minus Vd, where Vd is the voltage drop across the switch. So the average output voltage will be reduced by this factor, and similarly the average current, that is equal to V average by R, that will be equal to now D times the Vs minus Vd by R, so that will be slightly changed. Similarly the RMS voltage at the output of your converter will be 1 by time period integration from 0 to T on, but now you will be taking the square of the voltage that is appearing at the output and Vs minus Vd square, and then the under root of this one. So simplifying this one, you will see that this is equal to under root D into Vs minus Vd. So all the things will be updated according to the voltage drop across the switch. So similarly the RMS current will be equal to Vrms by R, so that will be equal to under root D into Vs minus Vd by R. And now the output power will be equal to Vrms into Irms, so that will be equal to under root D into Vs minus Vd into under root D Vs minus Vd by R, taking the expression of the voltage and the current. So if we simplify this one, that will be equal to D times Vs minus Vd square divided by resistance R, right? And now if we look at the input power, so input power will be equal to 1 by time period from 0 to t on Vs into I dt. Vs is the supply voltage and the I is the current that is delivered by our source. So that is equal to T on by T into Vs minus Vd divided by R. So this can be written as D into Vs minus Vd by R. So this expression will give you the input power. And what will be the average resistance or effective resistance at the input terminal? Let's suppose that is equal to Ri, and as we have calculated in the last slide, that is equal to Vs by I average. So this will be equal to Vs divided by and D into Vs minus Vd divided by R. So that will be equal to R divided by D into Vs minus Vd by Vs, right? And now we can find out the efficiency. The efficiency of the converter can be written as the ratio of the output power with the input power. So our output power is equal to D times Vs minus Vd square divided by R, right? And so that we have seen over here, and dividing it by the input power. So input power is D times Vs into Vs minus Vd by R. So simplifying this one, so the efficiency will be equal to Vs minus Vd by R. So the efficiency of this very basic circuit will be given by this expression, right? So now if you look at it from where we have obtained this expression, so this P naught is basically this one, that is the average the total power that was available at the output AC plus DC component. So that we have obtained over here, divided by your input power. Input power is given by this one, so we have taken the ratio of these two. So the efficiency will be equal to Vs minus Vd by not R, that will be equal to Vs. So let's change that one. So this will be equal to Vs minus Vd divided by Vs, right? So if I summarize this video, what we have discussed the operation of the circuit, which is consisting of the simple switch, that may be a BJT, IGBT or the MOSFET. I mean, we have seen that if we connect a resistance and we control that switch with the help of the duty cycle, what will be the output voltage, current, power, and how we can calculate the effective resistance in the efficiency of the converter circuit. So that's all from this video. Thank you very much.